So how do you graphically represent a particular relation? And it's quite simple. Of course, we'll be looking into a lot of problems where we'll be gradually looking at more complex cases, but to uh, bring the idea in a simple format and to make it very easy to understand, I have taken two simple sets. That's set A consisting of elements 1, 2, 3, and set B having elements 2 and 4. And not the point that the pairing up of element of A2 with that of the elements of B have haven't been drawn here or having been indicated in this particular uh, graph to make it less confusing. So the idea is very simple. We are having the coordinate plane, the Cartesian coordinates. We are having the x and y axis, and uh, so the important thing is that as I have mentioned earlier in a particular video, the axis can be used to represent the elements of a set. So you have the x-axis which represents the elements of set A, that's 1, 2, and 3, and you have the y-axis, that's the positive axis, where you have the elements of B as 2 and 4. Now a key point here is that in this particular case, you don't have to represent 1 and 3, and you can simply cancel them out. So 1 and 3 is actually not necessary. Uh, so how do you represent? It's very simple. It is you have the first point coming up here. That is one. This is the first point. That is element first element of A, that's 1, pairing up with the first element of B, that's 2, and on the upper side you have the first element pairing up with the second element of B, that's 1, 4. Similarly, as I already told you, the pairing up of 2 has been left because there isn't much space in this particular uh, graph, and it would be confusing. So I have already drawn that of 3. And 3 again, it follows the same procedure. There's 3, 2, and 3, 4. So and the elements that is the ordered pairs of this particular Cartesian product would be naturally 1, 2, 1, 4, then 2, 2, 2, 4, and 3, 2, 3, 4. Now we can represent the thing. I mean the Cartesian product in another form also, and we have already seen it in a previous discussion. So it's in a Venn diagram format, and it's very simple. And once again, to make the whole idea clear, I have chosen two simple sets. That's set A having elements 1, 2, and 3, and B having elements A and B. And you see, as you can see, be sure or please note the direction of the arrow. That arrow starts from I mean the starting location is the element which is doing the pairing, and the arrow ends at that point which is being paired. So here it's A times B. That's why the arrow is ending at the elements of B. So you have two arrows starting from 1, again 2 from 2, and again two arrows from 3, because we are having only 2 elements in set B. So it's 1A, 1B, again 2A, 2B, and 3A and 3B. So these two representations, that is the graphical and diagrammatic representations, is actually a simple process, unless the calculations become complex, and we'll be looking at those cases in the problem and the question bank sections. So thank you.